so today what we're going to be talking about is writing an equation when we're given data. So first, I want to review real quickly what an equation is. All right, this is a linear equation. It consists of our dependent variable y equals our slope times our independent variable plus a number, which is our y-intercept. All right, so let's define slope real quick. What is slope? All right. So our actual definition of slope is the rate of change of which y changes as we change x. So this is our rate of change of y as we increase or decrease x. As we increase or decrease x, all right? And our slope refers to the change of x by plus or minus 1. All right? So as x goes up 1, our slope tells us how much our y will go up in that same time frame. And then we have our y-intercept. And this indicates to us, int for short, our y-intercept indicates to us where, when we graph this equation, it crosses the y-axis, okay? A lot of times, this is where we start our graph. This is where the graph of our equation. The graph of our equation crosses the y-axis. All right. So again, when we're graphing, a lot of times we will start with our y-intercept, and we'll look at that when we get to actually looking at a graph. All right. But a lot of times, what we'll end up doing is we'll start out with a table, and we will need to be able to write an equation looking at that table. So now that we've defined our slope, what it is, as the rate of change of y as we increase or decrease x by 1, and our y-intercept, where it crosses the y-axis, we should be able to find, with data, an equation. All right, so let's take, for example, we're going to use this data right here, x, y. All right, we're going to use -3, 0, 1, and 2. And our data for these numbers are going to be -3, 3, 5, and 7. All right? -3, 3, 5, and 7. So at -3, our value is -3. Again, you can see how this plays out. So, as we look at this, we know that we are going to end up writing a y equals equation. Y equals something times x plus or minus something else. Okay? And we don't know if it's plus or minus, and we'll tell how to tell that in just a moment. So, we define slope as the rate of change as we increase or decrease by 1. So, we need to see in our table, is there any point where x increases by 1? So, we look here, -3 to 0 changes by 3, 0 to 1 changes by 1. All right? So, here is plus 1. If we can find how much y increases as x increases 1, that should give us our slope. So we go over to our y at 0 to 1, and we see that we increase by 2. Now, just to make sure that this is consistent, we have another example here where we go up 1 from 1 to 2, and here we also go up from 5 to 7 plus 2. So, as we know this number is our slope. This is our rate of change of y, 2, as we increase by 1. So our slope would be 2. So now we know that y equals 2x plus or minus something. Now we don't quite know what that something is, all right? So now that we've found slope, increased by 1, and our y increased by 2. Now what we need to do is we need to find our y-intercept. So, to do this is actually pretty easy. I know that I have a data set 0, 3, okay? And I know for a fact that my slope of this line is 2x. So what I can do is I can take this data set, 0, 3, and I can put my x value into my equation here. And when I see how much I have to increase to get y, that should tell me what my y-intercept is. So let's say I have y equals 2x, all right? And I don't know what plus or minus is yet, but I know that my x is 0. And when my x is 0, that tells me that my y should come out to 3. So let's just see if this is right first. 2 times 0 is 0. 0 does not equal 3. So what do I have to do to 0 to get to 3? If I have to increase, I would plus. So 0 plus 3. Now this is correct. Now this is correct. If I add 3 to 0, I get 3. So what this tells me, after I plug in my x value to my slope, the increase or decrease that I have to do to get to my y value becomes my y-intercept. All right, it's pretty simple. Again, we find our slope, then we plug any value in and see what we need to increase or decrease to get to our given y value at that x. All right, so our equation to this line is 2x plus 3. We can test that. 2 times 1 plus 3 should equal 5, and it does. 2 times 2 is 4 plus 3 equals 7. So this is our equation for this line. It's pretty simple. It's not very, very difficult, all right? But let's look at another one, all right? We're going to use another set of data, and we're going to find another equation. All right, so now what we're going to do is we're going to look at another example where maybe we don't have an increase of 1 in our x, and we have to do something different, all right? So, here's my x and here's my y. We're going to use negative 2, 0, 2, and 4 on my x, and my y values will be negative 10, negative 2, 6, and 12, I believe. 14. 14. Again, I'm just getting my data off of a calculator from a previously used equation, just so I can show you how to do this. So, here, we can see here that in our previous example, we were able to use our x value going up by 1. But we can see on this example, from negative 2 to 0 is plus 2, 0 to 2 is plus 2, 2 to 4 is plus 2. We don't have a clear-cut 1 increase in our x value. But let's go ahead and see what our y does. As we increase from our negative 2 to 0x, our y increases by 8. Again, from 0 to 2, our y increases by 8. And from 2 to 4, our y increases by 8. So we do have a steady increase, all right? Now, if we're looking for how much it goes up by 1, and we know how much it goes up by 2, we should be able to find out how much it goes up by 1 by dividing each of these by 2, correct? Because 2 divided by 2 would give me an increase of 1. And if we know that they're going up the same amount every single time, dividing our change in y by 2 should also give me my change in x by 1. So I know now that for every plus 1 on my x, I have plus 4 on my y. So let's go ahead and write this in our equation. Y equals 4x plus or minus something. All right, so just like our last example, we're going to take any of our x values here. We're going to take any of our x values here, and we are going to plug them into our slope only, along with our corresponding y value. All right? So, we look, let's use 0 just for informational use. If we use 0 when we do this if we're able to find 0, then it makes it a lot easier on us, because 0 times anything always equals 0, and we can immediately see how much we have to increase or decrease. So you might already see what we're going to have to do. So if we use 0, my y at 0 is negative 2 equals 4 times 0. So let's see if this is true. 4 times 0 is 0. 0 does not equal negative 2. So if we want this to both sides to be equal, we have to change our 0. We have to do something to it. 0 to negative 2 is a minus 2. Now 0 minus 2 does equal negative 2. So we know that my change in my y-intercept is minus 2. Alright? So it's not super difficult. Again, if my change in x is 2, we divide by 2. If it's a change in x by 3, we would divide by 3 to find our slope. Alright? So whatever your change is, that's what we would divide our change in y by to find our increase by 1. Alright? So this has been writing an equation using data. Alright, next time we'll look at, if we have a graph, how can we find the slope and the y-intercept of the graph. Alright, thank you.